Welcome to the video in lesson 4 from chapter 7. This one is specifically about the triangle inequality theorem. And so by the end of the lesson, we should be able to answer, how can we tell if 3 lengths can actually make a triangle? The triangle inequality theorem states that the sum of the measure of any 2 sides of a triangle must be greater than the measure of the third side. So the question is, can these lengths represent the sides of a triangle? And so what we have to do is we have to add all sets together. So 4 plus 5 needs to be greater than 6, so that's good. 5 plus 6 needs to be greater than 4, so that's good. And 4 plus 6 needs to be greater than 5, which is also true. So because these all work, yes, this can create a triangle. So let's go ahead and take a look at these. I'm just going to go in order that they're given. So I'm starting with 7 plus 13, which is 20. So that's bigger than 8, which is good. Then I'm going to do 13 plus 8, which is definitely bigger than 7. So that's good. And then I have 8 plus 7, which is 15. So that's bigger than 13. So we can say yes to this one. These lengths of sides can actually create a triangle. And if I double check this, the next problem in C, again, I'm going to start here. So 10 plus 5 is bigger than 5. And if I do 10 plus this 5, it's still going to be bigger than 5. So that gets like a double check. I'm not going to write it twice. But if I do 5 plus 5, is that bigger than 10? And this is the part where we're going to say no. And we're saying no specifically because this does not have an equal to bar here. This is just greater than. 5 plus 5 is not greater than 10. 5 plus 5 equals 10. So in this case, they cannot actually create a triangle. Okay, I want to go ahead and do a quick little video showing you guys about this 5, 5, and 10 and why the 2 sides of the triangle have to be greater than the third side and not equal to. So what I have here is I have 2 little rulers, and these are the same length. So these are going to be my 5. So 5, 5, and then I took 2 other rulers exactly the same, but I taped them together. So this is going to be my 10. So 5, 5, and 10. And I'm going to stack them on top of each other in an effort to try to create a triangle here. And so because they are 5, 5, and 10, you can see that when I stack them on top of each other, you can't see anything because they're stacked on top of each other. But if I do try to create a triangle here, the problem is that because they're equal to the base, the bottom part, when I lift the 5s up to try to actually create a 3-sided object, they can't touch each other because they are equal to the base. They're touching at the bottom. And the second I lift them up, they're no longer able to reach each other to actually close at the top to create a triangle. And that's why we need the 2 out of the 3 sides to be bigger than the third side, their sum to be bigger than the third side, so that way whenever we do lift them up, they do have the ability to touch at the top. That does not work when they are equal to. That's why it always must be greater. All right, let's keep going here. I'm going to take those first 2. 3 plus 3 is greater than 7. Okay, well that does not check out. 3 plus 3 is only 6. So that means that this is not going to be able to create a triangle. I don't even have to test the other sides because 3 and 3 will not be greater than 6. That one will not create a triangle. Over here now in problem E, starting with the first 2, and I'm starting with the first 2 just to keep myself organized right now. So 25 plus 10 is greater than 20, so that's good. 10 plus 20 is greater than 25, so that's good. And then we have 25 plus 20, which is definitely bigger than 10. So this set of sides will be able to create a triangle. Now, what I want you to realize before I get into this one, because the numbers are larger and I just don't feel like adding everything over and over again, what I want you to realize, especially with this first problem, is that it's the 2 smaller sides that really have to be bigger than that third side when added, the sum. Okay, so it's those 2 smaller sides, the 3 plus 3, needs to be bigger than the 7. 7 plus 3 is going to be bigger than 3. 7 plus 3 is going to be bigger than 3. That's not the problem. You want to test those 2 smallest sides to see if it's going to be bigger than the third side. So in this one, with the 25, 10, and 20, 25 is a big number, adding 10, that's going to be bigger than 20. Like pretty much if I include the 25 in the sum, in the addition problem, then they're going to check. So what I'm really interested in are the two smaller numbers. It's this one here. That's the one that gets closest to possibly not working. So in F, I'm going to look at the 21 and 30 only. So 21 plus 30 needs to be bigger than 50. Because the 50 is obviously greater than the 21, if I add 30 to it, it's going to be bigger. Because the 50 is greater than 30, if I add 21 to it, it's going to be bigger. The only ones that I'm actually really curious about is if the 21 plus the 30 is bigger than 50. And in this case, it just makes it 51 is greater than 50. So this does work, and we will be able to create a triangle using those side lengths. So try these on your own. Feel free to test all three sums, but remember that all you really have to focus on is the sum of the two smaller sides must be bigger than that third side. Checking your answers, the first and third one should be able to make triangles. The middle one, H, the 26, the 15, and the 10 cannot, because 10 plus 15 is only 25. It's not greater than 26. Okay, so let's now look at these problems where maybe we know two of the sides, but we don't know the third side. We have to keep in mind that this third side here, whatever this x side can be, has a variety of possibilities, really kind of depending on where this 6, where this red side falls. Like we don't know what this angle is, so I don't know exactly where this 6 is going. So for example, like if it's like as it is as pictured, then it stays there and the x is however long that is. But what if the 6 is here? Okay, well then that now affects my green side, that x side, to be shorter. Okay, or again, we move the red line even closer to the 15, and then that's going to make the green line shorter. So we have only so many options, but if we look at this, if I do take the 6 the whole way down, the green has to be the smallest that the green could possibly be, is it has to be bigger than being equal to, because remember the equal to doesn't work. So we could figure out this subtraction. Like if I took 15 and I subtracted 6, that gives me 9. That means that this green part has to be 9, but it can't actually equal 9, because if it just equals 9, then it can't actually continue to touch. Remember with the 5, 5, and 10, it can't actually continue to touch. So that value for the green actually has to be greater than 9. So now we've figured out that the smallest value that it could possibly be is something bigger than 9. It can't even equal 9. It has to be bigger than 9. But we also have to remember that when I add the 6 and the 15 together, that sum has to be bigger than that third side. So if I take the 15 and I add the 6 to it to get 21, that's the largest that it could possibly be, and that's not even, and I don't even feel comfortable saying the largest because it can't actually equal 21. These have to be inequalities. There's nothing equal about it. But my x value, the value for that length, is going to be greater than 9 so that it does actually touch when you lift those sides together. But it also has to be less than 21 so that the two sides that we do know are going to be able to touch whenever we lift it off the green side. So whether or not you understand how this is all relating together and why the math is working the way that it is, the math itself is actually very easy. When you have 2 out of the 3 sides, you subtract them to find the minimum value and you add them to find the maximum value. But even that minimum and maximum I'm using loosely. They will not equal to, okay? It's like a limit. Like it cannot go lower than 9, can't actually equal 9. It also cannot be any bigger in this example than 20.99999. It cannot even actually be 21. Otherwise, the 6 and the 15 won't work when they're trying to create a triangle there. So subtract them for that smaller value, add them for the bigger value. That third side must be between there somewhere. Okay, so all we're going to do is subtract the two numbers and add the two numbers, and that's going to give me my range. So I'm going to take the 12 minus 5, and I do the subtraction first because that's going to give me my smaller number, and I leave a little bit of a gap. I do my sum to get my larger number, and then I literally just write my answer just like that with X in the middle and the less than symbols. As long as you have the smaller number and then the bigger number, these will always be less than symbols. Okay, so we move on to the next one, 35. Take away 18, and then 35 plus 18 will give me either side of my, X values there, that length of the third side. So the length of the third side must be somewhere between 17 and 53 without actually equaling 17 or 53. And last one on this slide here, again, doing the subtraction first, simply so that it sets up my answer pretty quickly. And I just put the X in the middle with two less than inequality symbols. Go ahead and try these three on your own. Again, you are finding a range of possible lengths of the third side of the triangle. Subtract, add, the numbers for X are in there somewhere. Go ahead and check your answers here. For 20 and 25, that third side has to be somewhere between 5 and 45. The middle problem here has to be between 4 and 6, and the last one has to be between 6 and 70. Final two, just quick checks. 70 minus 50 is 20, 70 plus 50 is 120, so that value of the third side is somewhere between 20 and 120. And for the 9 and 19, that third side has to be somewhere between 10 and 28. So now that we've been doing problems that only have numbers in them with a single variable X, we're now going to take a look at these problems where there is an expression involving the X. And so what we have to realize is that there's still that range that exists. That third side, whatever it is, has to be bigger than that difference, but smaller than the sum. So if I add and do my addition and subtraction like before, that will give us a compound inequality that we'll be able to solve for X. So in this case, this 2x minus 5 side is somewhere between a length of 13 and a length of 41. So this is the this is the inequality that I'm solving here. Okay, so actually let me go ahead and rewrite that a little bit neater. Okay, so solving this compound inequality, this is something you guys did back in Algebra 1. We're going to add the 5 to all three pieces. So I'm going to get 18 is less than 2x, which is less than 46. And then I'm going to divide all three pieces by 2. So 9 is less than x, which is less than 23. So the length of this side has to be somewhere between 13 and 41. And in order for that to happen, the x value, the actual value for the number or for that variable there, has to be between 9 and 23. It has to be smaller so that way whenever we plug it in and do this math, the length ends up being between 13 and 41. Okay, so the steps include subtracting to find that lower range, adding to find the upper range, solving the compound inequality. So going through the motions again here, 20 minus 11 is going to give me the lower range of 9. 20 plus 11 will give me the upper value of 31. So that 2x minus 1 has to be between 9 and 31. So this inequality represents the possible lengths of this side based on the material that we were doing earlier where we have to have that range or else it can't create a triangle. When I solve by adding 1 to all three places, getting 10 is greater than is less than 2x, which is less than 32, and then dividing all three pieces by 2, this is now the value for x, or the set of the values for x, that could be plugged in here to get the 9 through 31. So 9 through 31 are the possible lengths of this side. Again, the values for x have to be between 5 and 16 in order for these restrictions to take place. So this concludes this lesson for the triangle inequality theorem, which says in general that two of the sides, you add them together of a triangle, they must always be bigger than the third side. Any two sides you add together must always be bigger than the third side. But specifically, the way the numbers work in answering this lesson essential question, you're really just looking at those two smaller numbers to make sure that they are greater than the third whenever you add those together, in order for them to make a triangle. We then use that information to find a range of possible values for that third side, which we then also apply to being able to find a value of a variable in an expression. So subtracting them, adding them, and finding that range, because there is only a certain amount of values, a range of answers, in order to create a triangle and actually have it close.